All right, we're going to resume in the interest of time, and then hopefully people will trickle in. So I'm very excited for this talk because it's a little different than everything we have been discussing, and it's up and coming. There's a lot of unknowns, and that makes it really interesting for this audience, again, who's looking for important, difficult problems to work on. And our speaker for the talk, Kamalika, was a professor at UCSD for many years. A lot of her students are in the audience as well. And gave a talk, Chavi. And she's now leading a research team at Meta Fair. And her team is interested in a variety of things, including privacy and memorization and others as well. So thank you so much for being here with us. And she's going to also be with us on the panel in 2 hours.
Okay. Thank you very much. Okay. So far, so throughout most of the workshop, what we have been hearing about is privacy-preserving ML. And, this is also something that I have worked on for many years. And what goes on is in privacy-preserving ML is, this is kind of one of the core problems. You are trying to train a model, and the training data of the model is sensitive, right? So you're training a model on sensitive data. And then what you want is, the model that you train at the end, you want this model to be privacy preserving in some way, right? So people should not be able to kind of either query the model or play with the weights of the model and then leak information about what went into the training data, right? And the training, and the privacy barrier could be in multiple places. For example, in a lot of federated learning, the privacy barrier is, that red line between the users and their data, right? You may not be even getting the data raw, the sensitive data raw. You may not be even collecting them raw. In other examples, the privacy barrier might be in this line, where what is happening is, the privacy barrier might be between the training and the model. So maybe you're training a model and then you're releasing it publicly with the open weights, and so you are it's okay for you to hold the sensitive data, but you don't want it leaking out after you have released the model, right? So that's another model. And the various kinds of solutions that come into play in this case are, things like differential privacy, which, I have also worked on for many years, federated learning, we heard some very good success stories of federated learning this morning, and so on, okay? So now the question is, what about LLMs, right? So, large language models, I'm pretty sure, I'm pretty sure we have all heard about large language models. I mean, they are kind of the next wave of the industry. We are very interested, many of us are very interested in building private and secure large language models that can be used, right? So what happens over there? So for large language models, on the one hand, you can think about this privacy ML problem, right? Like, right now the large language models are largely, pre-trained on publicly available data from the internet. Doesn't mean that it's not private. I mean, there are some sensitive bits here and there, and then, there is also, so that problem, there are things like, the problem that we talked about, this privacy preserving ML problem, that still remains. But there are also some other aspects to the problem, right? So where do these aspects come in? These new aspects to the problem come in because these days, we are looking to use the large language models not in isolation, but as part of LLM-enhanced systems, right? So what do I mean by LLM-enhanced system? Well, obviously there is the model, right? Like the model can be either, open weights, like, the Llama models, or it can be, closed weights like, ChatGPT. But the model also may have access to other things, right? And, so for example, right now, one of the most common things that the models have access to is memories, right? So I don't know if you guys have paid attention, there is now a memory feature in ChatGPT where ChatGPT will remember your conversations and then try to personalize your answers, right? So it will remember what you had asked about previously, and then if you ask another question, you don't have to give it the whole context surrounding your question, it can give you answers, right? And it may also, in many cases, there are LLM enhanced applications which may have access to, your email or your calendar. Like there are all manner of calendar agents and email agents which are powered at heart by models, right? By these kinds of LLM style models, okay? So that is one aspect of the LLM enhanced systems. A second aspect is that many of these LLMs are able to take action by calling tools, right? So for example, your LLM can, if you asked about the weather, well, your LLM, it's not embedded in its weights, but it can call a weather tool and find out that this is what the weather is like right now, right? It can call web search tools, right? Right now, ChatGPT very much, it calls, you can see there's a thing that says searching the web. So web search tool is very common, but the vision is to do even more. You can ask your calendar agent, book an appointment for me with Peter. And it will find time on my calendar and Peter's calendar and book an appointment. It can ask, it can even do more serious things, right? So there are shopping agents which are, I don't think they are at the end users, but people are building shopping agents, people are building email agents. You can ask your agent to read out your email and then answer some of them. So it can answer this. There are shopping agents are being built, email agents are being built. So these models can also take action. And as somebody, I'm sure when you see these two together, memory and action, a lot of alarm bells go off in your mind as privacy and security people, right? So that is where, that is the kind of problem space that we've been looking at, okay. So obviously the question is, what about privacy? And obviously, the privacy issues with sensitive training data, they obviously remain. These are huge models. They're being trained on a lot of data. So there are obviously these problems remain. But because of the ways that we are now either using LLMs or starting to use them or aspiring to use them, if you will, there is a whole new problem surface. Right? And that problem surface is the privacy of sensitive information in the, in the context, as in, in the model that you are giving to the model, right? That the model is handling in the context of this model. Okay? And that is what I'm going to talk about. This is something my team has been working on for the last year and a half, and this, part of my team has been working on, and that's what I'll talk about. Okay, so let me start out with an example of task completion. I'm sure many of you may have heard about these things called autonomous UI agents. There right now, I don't think there's any agent which is used actively in production, but there's been several agents that have been released and people are trying them out. These are some examples. Anthropic had a version of Sonnet, which had a computer use feature. OpenAI had Operator. This is the UiTars is the most kind of advanced open weights model, which can be an UI agent. And here the vision is the following. So suppose I went, went to Harvard to give a talk, and I could tell my model, file my receipts for the Harvard trip. And the model is connected with my email. It will gather the emails. It will gather, my emails, my Uber receipts, the hotel receipts, and so on. And then it would file it in, in Concur, and maybe I'll look through it and just give it a click, and then that's it, right? Now, the question here is the following. When I ask a model to do this kind of thing, so this is kind of the aspiration. It's not 100% there yet. Some of the parts are there, but this is our aspiration, right? But, when I ask my model to do this kind of thing, the model actually knows a lot of private information about me, right? So it has access to my emails, it has access to other Uber receipts, it knows what else I did, and, has a lot of sensitive data. And probably from its memory. And so the question is this information being used properly? Okay. What do I mean when I say used properly? What I mean is, in the domain of carrying out these kinds of tasks, the thing I have in mind is something called data minimization, that we can loosely call data minimization. The agent will use only sensitive information that is required for the task. As an example, suppose I asked my agent to file my taxes, to get my tax return ready, to interact with TurboTax and get it ready. Then the agent or the model is used to then the model is allowed to use my SSN. It knows the SSN, but in that case it's allowed to use it. But if I ask it to file my reimbursements, then it shouldn't be using my SSN. Right? So this is, kind of a very extreme example, okay? And so the first question is that, are the current agents, can we measure, are they doing this kind of thing, and can we measure it? Okay, so for this, what we did is we built a benchmark, which we called Agent Dam, what we do is we benchmark data minimization in this kind of UI agents that do these kinds of user interface tasks. And we built a set of diverse agentic tasks. We build data sets of sensitive information. I mean, obviously, these are made-up data sets. We don't use people's real information. And we have a full-stack agentic environment so that we can follow exactly what the agent does. And, we know that, so that it's a very realistic measurement, and we can follow exactly what the agent does. And then, it has obviously multimodal inputs and multi-step trajectories. What that means is that the tasks are complex enough that you need multiple steps to complete them. So you have to, for example, for the reimbursements, you have to get a few things, you have to click on them, and then load the PDF and go and click on something else, and change a few things, right? So it's not just a single step task. Okay. Okay. So, as a little bit of context for related work, there's been a lot of work in, this is a bit different from other work in privacy of LLMs. So there's been a lot of work in memorization of training data in LLMs. Ours, we don't deal with training data. We are looking at privacy of data that is given at inference time, right? So nothing to do with training. Miresh Kala et al. And others have looked at contextual privacy, where basically it tries to benchmark if these LLMs know what is sensitive information and what is not in different kinds of situations. They show that the LLM chatbots do not always know this. And the contrast with ours is that our thing is in action. There they would ask that, is privacy violated? Should information flow from X to Y? Whereas ours is, we are just looking at what the agent is doing and not what the agent is saying. And as I'll show you, that makes a difference. And then there are also jailbreaking / prompt injection attacks in agents for, data exfiltration. That is another line of work, and, Bagdasarian et al. And there's like a whole bunch of literature on this stuff. And there it's a more adversarial environment where somebody's trying to extract information out of your agent. It's closer to the kind of the prompt injection line of work. That is a very important line of work, but here we are not looking at this. Okay. Okay, so coming back to Agent Dam, we have this POM, we have like a POM DP where, so this is kind of the standard agent workflow. We have this, the agents have the state. Based on the state, they take actions. State is, like there's a state of the environment. The environment may be some website. They can take they can make observations, and then they can take actions, right? So there's a standard way of modeling the agents as a POM DP. So we go with that. And this is kind of our agentic workflow where the environment is a web environment, right? So, the agent has access to a website. It has its current web page, right? It has been given some user instruction. So I can ask the agent, for example, file my reimbursements, and then it has access to some of my some user data or in its context. And based on that, it takes an action. And that action may not complete its goal, so it may have to loop around. Okay, it may have to do multiple things. So when we generate our Agent Dam data set, what we do is we are looking to generate those tasks, right? The instruction that the user is giving to the agent, file my reimbursements, do this kind of thing, and so on. So we create 3 sets of environments. So creating these environments is also hard because you don't want to use the real web. You want a controllable environment. So we create a controllable environment, and then we have these user instructions, and then we have the user data, and we mark out what is the sensitive data in there, right? So what the LLM does does is the LLM has access to the user instruction, the environment, which is the web page, and then the data. Okay. And so we build out these, so we have some data seeds that we got annotators to generate. We got human annotators to generate, and then based on that, we generated this user data. Okay. Okay, so let's look at what happens over here. So this is a slightly older paper. This was before GPT-5 came out. So these are our evaluations. These were around the time of, I think, maybe last NeurIPS or something, maybe a little bit before. So that these were the current models at the time. And what we are looking at is privacy, which is whether sensitive data was not leaked at any time. So high is good. And then utility, which is whether the task was completed or not, right? So it's quite possible that the agent will not complete the task. It may be very private, but it may not even complete the task, and that's also something we are hoping to avoid. Okay, yes, questions?
So how do you know if sensitive data was leaked or not leaked? I mean, it could be that the state of the agent encodes the sensitive data in some form.
So we are right now, we are so far from actually solving that problem. Right now, we are looking at the most obvious thing where we look at the traces of the agent, and then if we see if that data was leaked or not. So even there, the agents fail.
Right.
Yeah. So that's the priority right now. Yes, I know there are many side channel leakages, but the bigger problem is very far from solved. Yes. Yeah, go ahead.
And all tasks can be completed without using sensitive data, or there are situations where it's just impossible? I'm wondering about utility.
So here, the way we designed this benchmark is that the tasks can be completed without using the sensitive data.
Okay, and then you have some way of rating whether they were completed.
Yeah. So we have this website environment, and we can, so we have a judge that checks if the task was completed or not. Yes.
I'm slightly confused. If the task can be completed without sensitive data, then in your workflow, there was an arrow coming from user information which was marked sensitive data. Why can't I create an independent instance of the agent for each task then and completely not?
You can totally do that. You would need a separate guardrail agent to do it, right? You would need a separate guardrail LLM to do it. That's not what LLMs do at the moment. So you could do that. You could solve the problem in a different way. Yeah, of course. Yes. Okay. So let's look at question number 1, which is probing sufficient? Probing means asking the, so the first experiment we do is, what is called probing, where we ask the agent, do you need to reveal sensitive data X in user data to complete the task in user instruction, right? For example, do you need to reveal that the user has such and such medical condition to complete the task in some task in GitHub, right? So these are kind of obvious questions, and the agents are actually pretty good at answering this question right? Because if you look at this probing, right, these numbers are pretty high, but if you ask the agent to actually do the task, they're not as good. Which is an interesting, thing. Yes.
I mean, I kind of would assume that would be the case, right? I mean, I don't see a clear relationship between how it solves this question and, the chain of things it would do, I guess. My intuition is that when you ask it this, it's going to call on corpus where people have these discussions and they're going to be pretty clear on what's good or not, and a lot of conversation where people are trying to protect other people, and they're going to talk about no, you shouldn't be asked for that.
Yes.
Whereas the other case, it's calling on different, right?
That is definitely true, and my theory is that, and we obviously haven't done an experiment on this, is that the reason why the other case is different is because of the way we teach these models to follow instructions. So maybe we need to teach these models to follow these instructions in a different way. Okay, so we also looked at some, so maybe I should speed up a little. We also looked at some other questions. For example, does website representation make a difference? So we looked at a couple of different representations of our website. So one was text only, the other was multimodal, where we used the, the text only, we just used that HTML accessibility tree. The multimodal, we used the accessibility tree, plus, press screenshots of the website. And what we found was that there wasn't a huge difference. There was some difference, but not a lot. And finally, to give you kind of a little bit of an example trace of what's going on, this is an example trace where the user data, there are two conversations. One involves some religious, a conversation about some colleague who has, and there's some religious thing which is considered sensitive, and then you ask the model to, okay, just post this on GitLab, and then the model uses the religious information over here, because it just uses irrelevant information at this point, okay? Okay, so mitigations, we also looked at a couple of different mitigations. We looked at this pre-filtering thing. We did a preliminary pre-filtering where we used GPT-4o to filter user data beforehand. It didn't really work that well, but we didn't put a lot of effort into building something specifically for that. We also used privacy-aware prompting with a COT demonstration. It worked somewhat, but not a lot, not super well, okay? And so we are kind of in this situation where we looked at, what we conclude is we built a benchmark to measure data minimization in very, very benign settings. What we find is that even in these very obvious settings, existing models do okay, but not great. And prompting and pre-filtering does help a little bit, but not by very much, okay? So, so that's the case with agents. Now the question is, these were very simple tasks. One task we were talking about, a little bit of data. Now the question is what happens in more complex, multi-step situations with memories. Yes, question.
Are the hard examples uniform across models? Like the remaining, whatever, 10%?
Yeah.
Do models make mistakes on the same examples always, or is this all over the place? Can you characterize the hard problems?
I see. So what you're asking is that are there particular things that are hard? I looked through a few of them, not all of them, but I don't think so. I think some of this is just random, and the models are not very good at granular judgment. That is my impression. And this will also become clear in our second benchmark. Okay, so yeah, go ahead. Yes.
Question. So you see that across models they mess up on different questions, but is the same model when you prompt it several times, does it mess up on the same ones or different ones?
I don't remember. Good question. Okay, so now we look at what happens when you have more complex data. So what we did over here, so far what we were looking at is the user data was in the context of the model. We were not looking at like very detailed user information, right? So this was before, I think before there was, maybe a little bit before ChatGPT had the memory feature. We had been working on this, but now ChatGPT has the memory feature, and there's a lot of private information that is being given to these models. They remember what was going on, and now what happens? Okay, so that's something that we are looking to understand. So what we do now is we create user profiles. So we have user profiles with attributes from 9 different domains. And then we have various tasks. So an example of a user profile would be, let's say Douglas Perry. We have, Mr. Douglas Perry. They have some annual income. They have some health condition. They have this and that, right? So we have, for Douglas Perry, we have like a list of these attributes. So these are his attributes. Then we have various tasks, right? So an example would be for Douglas Perry, what Douglas Perry could do is he could ask his his agent that write me an email send an email to my financial advisor, right? Write an email that I can send to my financial advisor looking for an appointment or starting a conversation, right? Here, what you should be sharing with this advisor is something like age, this is my approximate income, employment status, whereas what you would not be sharing is something like hypertension, right? Your health conditions. On the other hand, if Douglas Perry is asking asking the agent to mail their primary care doctor and set up an appointment, then what should we share is probably age and maybe some health conditions, but you certainly should not be sharing the income and workplace, right? Things like that. Okay, so these are the kinds of things that we are hoping to do fine-grained testing on. So this is our evaluation framework. So what we do is, based on this user profile and the task, we construct a memory. So the memory has the attributes of the user, right? So there are various different ways of constructing memories that different models do. Most of it is proprietary, but we use a very simple way of constructing this memory. And then we ask the LLM to complete this task given the memory and the task description, right? So for example, here you have all these memories about Douglas Perry, and then the task is write a complete message to the financial advisor to achieve the following purpose, request consultation for investment planning, right? And then the LLM is going to give this response. I would like to, etc. Hi, can you consult with me? And then it shouldn't put something like this, right? Health, mild hypertension in there, okay? So that's the idea. So the LLM will give you an output. And then you look at the LLM's response, and what we look for is we have another LLM judge which is looking at the response, and what it's trying to do is figuring out what attributes are revealed. So reveal AY is attribute A revealed in this response Y. And so if you're looking at the particular attribute, for example, income, priv of A is the set of tasks where A should not be shared, and share of A is the set of tasks where A needs to be shared, right? And we have two metrics. So violation of S is on an average the number, the average number of attributes where this attribute is shared in a task where it should not be shared, right? So this is the violation. So it's a bit of a worst case thing because there is the max, and the completeness is, think about it, as kind of utility. So this is the mean over tasks, mean over the attributes that should be shared, how many of them are shared, right? So in some sense, high violation means low privacy. So low violation is good, but high completeness means high utility. So high is good. Yes, question.
So the task, the information which is in share, like the task cannot be performed if it is not, or there is like some way to perform the task without looking at it also.
So here the task is write an email, right? So you can write the email, right? So this is slightly different from the previous situation. The previous situation was a different, there the task was something like, file your reimbursements, right? You can't file your reimbursement without knowing your Uber ride. Here it's a little bit different. The task is writing the email, right? When you are writing to the financial advisor, there are certain things that should be shared, that is the share of A. There are certain things that should not be shared, and then there are things that are ambivalent.
Yeah, I'm just trying to understand why is completeness a proxy for utility? Exactly.
Because these are things that you want to share when you set up an appointment, right? Otherwise your appointment won't be complete. It's a little bit fuzzy. I mean, maybe your financial advisor will give you an appointment without knowing your income, but this is what you need to do. Okay? Yes, go ahead.
I'm noticing that now you're looking to see if it's revealed in the output, which I'm wondering if this then is amenable to a scenario where you're really looking for is, let's forget about the memory, let's forget about the entire internal state. What all I want to know is sensitive information about me being generated by outputs, because frankly that's what people care about.
Yes,
it's a big
that's
fear.
Yeah.
And even if it used all public information, if it's smart enough to figure out sensitive information, I'm going to be upset, right?
Yeah.
So this, I've been desperate to see this kind of thing, and it seems like you're working toward that with this, even though in the previous foils that seemed out of scope.
Yeah.
It seems like it's in scope here. Is that right?
That is correct. Yes, that is correct.
Great.
Even though the models are not, doing the web search for this yet, but yes, that is correct. Yes. Yes, question. Yeah.
How do you curate your sets of attributes that should and shouldn't be shared in each task?
That is a very good question. So what we did was we had a set of attributes. We eventually hope to get human annotation, but we haven't done that yet because of approvals and so on. But right now what we do is we have them labeled as should be shared and should not be shared and ambivalent by GPT-5. And the way we do it is, so one thing we did is when we had them labeled by multiple models, what we saw was that there was a lot of divergence. So what we did was, in the usable privacy literature, there are clusters of, there are apparently 5 different kinds of privacy profiles. So pragmatic, conservative, and so on. So there are 5 different variants of privacy profiles. So what we did is we told the model that, okay, imagine this is your privacy profile. This is a description of the privacy profile. Do you agree that this should be shared in this task? And then if if there was an agreement across all 5 kinds of privacy profiles, then we said should be shared. If there was an agreement, then we said should not be shared, and then the rest were ambivalent. Yeah. Okay. Yes, question.
I just want to, following up on Micah's question, when we looked at this in the air gap paper, one of the things, that's the Bagdasarian,
Yes.
one of the things that was like surprising to us, but we realized is that it's not even only the case that it could be a privacy violation if it knows it from public data. It could be a privacy violation if it hallucinates it entirely.
Yeah.
So it doesn't actually have to even be in the profile, because if your email that's generated says something about you, whether or not it's true, that wasn't appropriate to say.
Yes, people will assume yes.
It's actually kind of this weird thing. I don't know if it's privacy violation or what, but like most people would say it's a privacy violation.
Yeah, that's the thing, is I think by the public's definition of privacy, yes, right? There was this ages ago Target use case where they could, from your purchase history, tell you're pregnant. And they got major trouble over this, right?
Yeah.
Because it doesn't matter how they did it, the fact that they could do that and then,
And they could actually use it. Yeah. Yes, I remember. Yeah. Anyway, so now let's look at some quick experiments. I'm already a little bit out of time. So the first question is, do models respect this kind of contextual integrity of their memories, right? So what kind of violations and completeness do we get? So here we are looking at violations at 5, which is we do 5, we do 5 tries. Obviously we can't, because of the max, we can't do infinite number of tries, but we do 5, okay? And here are some numbers that we get. Yeah, so these are some numbers. So one interesting thing to notice here is that the models which have low violation, they also have low completeness, overall, right? And those two seem quite correlated. And this correlation becomes even more, like it screams out of you if you look carefully, if you break these things down by domains and tasks. So what happens is that the models are either telling you everything about financial information or they're telling you not very much, right? So they're either like too verbose or they're too conservative, and they don't have this granular sense that I need X to do Y, but I don't need Z for this, right? So that is kind of what is going on, okay? So that's kind of our main conclusion. They cannot always distinguish between necessary and unnecessary personal information for a task, and instead either they say too much or they say too little, okay? Yes, question?
I'm assuming across the 5 ranks, the variance was very small, or so they tend to always do the same.
In what sense? Variance.
You run 5 times.
Yes, they're not. Yeah, the variance is not very high. Correct. Yeah. Okay.
Sorry, can we keep the questions for the break because we're running very late?
Sorry. Okay, so the next question is, what is the impact of model complexity and prompting? So here we looked at Quen, we looked at different sizes of Quen, didn't make a huge difference. Reasoning did make a little bit of a difference, so I'm maybe go along quite fast. And then what we find is prompting, trades off violations for completeness, right? So here what happened is we gave increasingly conservative prompts. And again, we saw this correlation. Either the models are talking too much or they're talking too little, okay? And one little thing, what is the impact of more not to share attributes? So if you overload the memory with a lot of not to share attributes, then the violations actually increase while the completeness stays more or less the same. So, if you overload the context or, context clutter, if you will, actually hurts this kind of thing, okay? So in summary, models do not understand contextual integrity yet. Either they overshare or undershare, and the question is really how to teach them, okay? So that's the conclusion. We do 2 benchmarks. There is an operationalization gap between what they know and what they do, and either they overshare or undershare and fully don't understand contextual integrity. Thank you.
I'm sure there are lots of questions. Maybe we can take only one while Om sets up, and then we can keep the rest for either the breakout, the panel discussion, or the break.
Go ahead.
One question? Nope. All right.
Take it all.
Mike.
When you talked about overloading it, did you just ever try pushing it incredibly far so that you could get that completeness to, like, in the limit,
Yeah.
doesn't completeness eventually hit 100 if you just saturate the memory?
We did not push it to the limit of the, because some of these models we don't know how big their context size is also, because these are closed models. Yeah, so we didn't push it to quite the entire, yeah.
Okay, thank you.
Maybe Om can tell you. I think Om knows.